In this video, I'll be going through a statistics and mechanics practice exam. All of the questions are based on past Edexcel exam questions. I suggest you give all of these questions a go before you watch the solutions. So you can either download the paper, which will be linked in the description, or you can pause the video on each question. Let's get into it. In one of the statistics section, it says a partially completed table below summarizes the times taken by 100 competitors to complete a puzzle. Here we have the table. It says a histogram is drawn. The bar representing the 0 to 2 interval has a width of 1 centimeter and a height of 3.5 centimeters. Part A says given that the bar representing the group of 6 to 10 has a height of 11.75 centimeters, find the frequency of this group. For this question, you need to know that the area of a histogram is proportional to frequency. Now, it's often the case that area is equal to frequency. If it's not, you need to find the constant of proportionality, and that will allow us to answer this question. We can do that using this piece of information. They tell us the area, well, they tell us the width and height, which allows us to calculate the area of the bar representing this interval. So the width is 1, the height is 3.5. That gives us an area of 3.5. And this will equal the scale factor times the frequency of that interval. So here we have a frequency of 7. So we're going to have some scale factor multiplied by 7. And we know 3.5 is 1/2 of 7. So the scale factor is going to be 1/2. So in this case, for this histogram, we have that the area is equal to 1/2 times the frequency. We can use that now to answer this question. So we know the height, we can find the width. The width of the interval from 0 to 2 is 1 centimeter. And so the width from 6 to 10 will be double that because the interval is twice as large. So we're going to have a width of 2 centimeters. So let's write that down. We have a width equal to 2 centimeters. So the area is going to be 2 times 11.75, which is 23.5. So then we have that 23.5 equals 1/2 times the frequency. And then we can see that the frequency will be 2 times 23.5. So the frequency here for this interval, 6 to 10, will be 47. So we can fill that in. Okay, that was part A. Part B says use your calculator to estimate the mean and standard deviation of times taken by the 100 competitors. For this question, firstly, we want to fill in this last interval, the frequency of this last interval. So let's add these all up. We know there are 100 competitors, so the total should be 100. So let's add these up. 7 plus 15 plus 47 plus 19, get 88. So that means there must be 12 in this last interval. So now to use a calculator to find the mean and standard deviation, you want to use the lists. So go to statistics. Well, it depends what calculator you have, but generally it'll have some statistics function, and in there there'll be some lists. So you want to go to edit and you'll have these columns. In the first column you put the midpoints. So the midpoint of 0 to 2 is 1. 3 to 6 is 4.5. 6 to 10 is 8. 10 to 14 is 12. And the last one, what's that? That's 28 plus 14. That's 42. Divided by 2, that's 21. Okay, so put your midpoints in, then put the frequencies. So 7, 15, 15, 47, 19, and 12. And then again go to the statistics menu and then go to calculations, then go to one var stats, one variable statistics, press enter, and then use the lists that you've entered. So list 1 and list 2, and then press enter. That will give you your statistics. Also make sure that n is 100 in case, that's like a double check that you put the numbers in correctly. So x bar in this situation is the mean. So we have a mean here of 9.305, and the standard deviation is 5.185, which I'm going to round off to 2 decimal places. So 9.31 and 5.19. Okay, Part C says the lower quartile of the times is 8 minutes and the upper quartile is 12 minutes. For these data, an outlier is classified as any value greater than Q3 plus 1.5 times the IQR. Showing your working, explain whether or not any of the times taken by these 100 competitors might be classified as outliers. Okay, so we have the IQR. That's going to be the difference between the lower quartile and the upper quartile. We can see it's 4, so let's just say IQR equals 4. Q3 is 12, so we're going to have outliers which are greater than this. So outliers are greater than 12 plus 1.5 times 4. So let's just calculate that. So 12 plus 1.5 times 4, 18. So we have outliers greater than 18 minutes. And so to answer the question, explain whether or not any of the times might be classified as outliers. What you want to say here is that because we have an interval here of 14 to 28, and we have 12 people in that interval, there's a high chance that some of those will be outliers. So just to finish that off, you could make that statement. So as there are 12 people within the 14 to 28 group, there's a high chance some of those are outliers. Part D says candidates with the fastest 5% of times for the puzzles are given prizes. Estimate the time taken by a competitor below which they might be given a prize. So the fastest 5%, well, seeing as we have 100 people, that's going to be the fastest 5 people. And as we have 7 people in the 0 to 2 interval, all of the fastest people will be within this interval. So we're going to have 5 people in that group of the 0 to 2 minutes group. Just write that down. Actually, I should make a note of the calculation we did. So we said 5% of 100 equals 5. And they're all within this group. And so now you want to assume that those 5 people or those 7 people are spread out evenly across that interval. In other words, because we have an interval of 2 minutes, we will have, the times of each of those people every 2/7 of that interval. So that's how you find the fraction. So let me just draw a little picture. So let's say we have an interval from 0 to 2. We have 7 people in here. We're assuming that they're spread out, at even intervals. And that's not 7, so I needed one more in there. Let's see if I can get this even. 1, 2, 3, 4, 5, 6, something like that. And each of these fractions is, we're dividing 2 by 7, so 2/7, right? Each of these bits is 2/7 of the interval. So in other words, we have the first 5 people will be 5 lots of 2/7, and that will be the time. Okay, so that's the general idea. So we're doing 2/7 times 5 to get the time below which those people won a prize, which is 10 on 7, which is, let's get a fraction for that, or sorry, a decimal. 10 on 7 gives us approximately 1.43. 1.43 minutes. So you had to get a time of 1.43 minutes or faster to get a prize, according to this sample. Okay, that was question 1 for a total of 9 marks. Question 2 says Daphne has a refrigerator with 5 temperature settings. She usually keeps it set on the middle setting. On the middle setting, the temperature in the refrigerator may be modeled by a normal distribution with mean 4 degrees Celsius and standard deviation 0.5 degrees Celsius. Part A says, using the model, find the probability that when measuring the temperature in the refrigerator, the temperature is exactly 4.5 degrees. And part 2 says more than 4.5 degrees. So something you should know about modeling continuous data with a normal distribution, if you're ever asked for the probability of exactly one value, that probability is going to be 0. So that's a consequence of the fact that the probability on a normal distribution is represented by area. So if you want the probability of a certain range of values, that's okay. You know, that will give you the area, or that area will give you the probability. But if you want the probability of an exact value, that's like asking the area of a line, which in other words, the line does not have area, so we get a probability of 0 here. So the answer to part 1 is 0, and that will always be the case when you're talking about continuous data and a normal distribution. The probability of exactly one value will be 0. For part 2, it says calculate the probability of more than 4.5 degrees. So we had a mean of, what was it? Mean of 4 degrees, standard deviation of 0.5. We're looking for the probability of more than 4.5. So it's going to be up here somewhere. We're looking for this area. We can use our calculators for this. Use the normal cumulative distribution function. That's in your distribution menu, probably on your calculator. Looks like this, normal CDF. And usually you want to put in the lower bound. In this case, the lower bound is 4.5. The upper bound is some large number. I use 9999, but well, that's usually big enough. That's usually enough. Then you want to put in the mean. In this case, the mean is 4, and then the standard deviation, which is 0.5, and that will give you the probability. So 0.1586. So probability of x greater than 4.5 equals 0.1586, which we're going to round off to 3 significant figures, 0.159. Part B says Daphne thinks that a temperature of less than 3 degrees is too cold for the middle setting. She tests the temperature on the middle setting on 5 randomly selected days. Given that the probability of the refrigerated temperature being less than 3 degrees is 0.0228, find the probability of the refrigerated temperature being less than 3 degrees on only the first of these 5 days. Okay, so this is now essentially a binomial distribution because we have, you know, probability of success or probability of an event happening. They've given us that, so we could write down P equals 0.0228. That's the chance that the refrigerator is less than 3 degrees. And the probability of this happening on only the first of these 5 days will be, well, on the first day, we have this probability, so 0.0228. Then on the next day, it's more than 3 degrees. In other words, it's 1 take 0.0228 chance of happening. And then we're going to multiply that by itself 4 times for the next 4 days. So in other words, we're raising this to the power 4. That will give us the probability of x being less than 3 degrees on the first day. On the first day. So all we need to do is calculate this. 0.0228 multiplied by 1 take 0.0228 to the power of 4. And we get a probability of 0.0207, 0.02079, which I'm going to round off to 0.0208. And it might make sense to convert that to a percentage, so it's a little bit more meaningful. So 2.08%, to me, that's more meaningful than 0.02, but you know, it doesn't really matter. You could leave it as a decimal if you wanted. Part 2 said on more than one of these 5 days. Okay, so we want it less than 3 degrees on more than one day. This statement is the same thing as saying 2 or more. So more than one is the same as saying 2 or more. In other words, it's more than 3 degrees, or sorry, 3 degrees or more on 3 or less days. So let me just make a note of that. Why did I bother doing this? Why did I convert 2 or more to more than 3 degrees on 3 or less days? Well, typically the function, the calculator that I'm about to use, the binomial cumulative distribution function only calculates probabilities less than a certain value, not more than. So that's why I've converted it to 3 or less days. And we're going to have to use a different probability of success. We're going to say that P is 1 take 0.0228 because we're now calculating the probability of the temperature being 3 degrees or more on 3 or less days. And the chance of that happening is 1 take 0.0228. Okay, so then go to the distribution menu, go to the binomial cumulative distribution function. The syntax here is that you firstly put in the sample size, so we're talking about 5 days. Then you put in the probability of success, it's 1 take 0.0228, and then the maximum value, so here it's 3 because we want 3 or less. And then the calculator does its magic and we get 0.004965. So the probability of x greater than or equal to 3 on 3 or less days is equal to 0.004965, which I'm going to round off to 0.00497. Okay, and that as a percentage, if we multiply that by 100, this will be 0.497%. Okay, that was part B. Part C says on the warmer setting, the refrigerator temperature may be bounded by a normal distribution with standard deviation 1.5 degrees Celsius. The probability that the refrigerator temperature is more than 8 degrees is 0.1. Find the mean refrigerator temperature on this setting, giving your answer to 1 decimal place. Okay, so this is like reverse finding the mean. So we're given the standard deviation and we're given the probability of it being, the temperature being more than 8 degrees of 0.1. We can find the z-score that's associated with this probability. That will be our first step. So for part C, let's say the probability of 10% gives us a z-score, which we'll need to calculate. The z-score of, we'll use the inverse norm function on your calculator. Find that in your distributions menu and then put in 0.1, and that will give you the z-score associated with that that probability. Now, because we're talking about more than 8 degrees, I should have put in 0.9. That would give you the positive z-score, but you'll still get the same number. So I can write in the positive value, which will be 1.28155, which I'll just round off to 1.2816. That will be enough to get an accurate answer. Okay, so that's the z-score. Remember how we calculate the z-score? The z-score is equal to the mean. So let's just write x bar, take the x value. And actually in this case, I'm going to do it the other way around because we're talking about more than, not less than. So we take the x value, take the mean, and divide by the standard deviation. So we have all of these things except the mean, so we can find the mean. Z-score is 1.2816. The x value is 8. The mean is, sorry, we don't have the mean. We're trying to calculate the mean. The standard deviation is 1.5. And then we can calculate x bar. So multiply this by 1.5. And I'm just going to multiply by -1 to get rid of that negative. So 1.5 times this z-score will be 1.9223. Okay, so let's just write that down. That's 8 take the mean. So then the mean must be, or if we rearranged, the mean would be 8 subtract this value, 1.9223. So let's do 8 take that answer. And I get 6.0776. And we need it to 1 decimal place. So this is going to be 6.1 degrees Celsius for the mean. And that was question 2 for a total of 11 marks. Question 3 says Sam is investigating the weather throughout the year in Herne. He uses the large dataset to investigate the daily mean wind direction. Sam believes that each cardinal wind direction is equally likely in Herne. Assuming that Sam is correct, state the probability that the cardinal wind direction in Herne on a randomly selected day is north-northeast. So for question 3, part A, part 1, we need to know how many wind directions are classified in the large data set. Now, if you didn't remember that, you could probably figure it out or sort of take a guess, because if you know what this notation means, north-northeast, you could draw a little compass for yourself. So here we have north, south, east and west, and then we have northeast, and so we divide it into eighths, and north-northeast is dividing into sixteenths. So this is north-northeast here. Now, because they've given us that, that notation, that tells you the compass is split into sixteenths, which is all of the classifications in the large data set. So even if you didn't remember that, you could possibly have figured it out just based on your knowledge of that notation. So it is 1/16 here. That is the answer, as there are 16 wind directions classified in the large data set, going around the compass, if you like. So part 2 says state the distribution that Sam should use to model the probability of each cardinal wind direction in Herne on a randomly selected day. Now, given that he believes that each wind direction is equally likely, this is going to be a discrete, uniform distribution. Discrete because the wind directions are discrete variables. You can only have, north or north-northeast or whatever. When they model this, when they classify it in the large data set, they give them discrete directions. And because he believes it's equally likely, it's uniform. So discrete, uniform distribution. Part B says Sam decides to investigate the daily mean wind direction throughout the year. State a limitation of using the data for Herne from the large data set as a sampling frame. So he wants to investigate throughout the year. You should know that the large data set is from May to October, so it's not the whole year. So that would be the limitation I would list. LDS only has data from May to October. Okay, part C says explain how to use simple random sampling to select 36 days from a year. Simple random sampling is this idea of picking numbers out of a hat, essentially, or like the lottery. So you want to assign each day of the year with a number, and then you want to use a random number generator or some other function to pick numbers, to pick days from the year. So that would be how I answer these type of questions. So I would say assign numbers to each day of the year and use a random number generator to select 36 numbers in the range 1 to 365 or 366 if it's a leap year. Okay, so that was part C. Part D says Sam defines the random variable x as the number of days out of 36 on which the daily mean wind direction in Herne is between the bearings 135 degrees and 225 degrees. Sam collects data from 36 randomly selected days and finds that x equals 15. Sam carries out a hypothesis test at the 10% level of significance. Given that HO, or the null hypothesis, is that p equals 0.25 and that the critical region is 4 greater than or equal to x and x greater than or equal to 14. Part 1 says state the alternative hypothesis H1. Some of this I think is a little bit confusing. Remember that Sam believes that each cardinal wind direction is equally likely in Herne. So that's what he's testing. And having a careful look at the angle that he's measuring between, or the angles that he's measuring between, maybe you notice something. We have 135 to 225. How many degrees in that interval? So 225 take 135 equals 90 degrees. So that's the quarter of the total directions that the wind could be blowing, right? So that lines up with the null hypothesis. that the chance that the wind direction is in this interval is 0.25. That's what he's testing. In other words, he's testing that the wind direction is equally likely in any direction. So what would the alternative hypothesis be? That will be that the wind direction is not equally likely in every direction. Okay, so for part 1, h of 1 will be that p does not equal 0.25. Could be greater than, could be less than. In other words, we're saying there will not be a 25% chance it will be in this interval. Or there might not be a 25% chance. And if we have a look, just on face value, he measured 36 randomly selected days and he got an x value of 15. That's almost, a bit less than half in this one interval. It's likely that we're going to be rejecting his hypothesis, but let's see. So for part 2, we've set up the test and they've given us the critical region. So we don't actually need to calculate anything here. We just need to interpret the information they've given us. So the critical region is less than 4 and greater than 14. X equal to 15 is clearly greater than 14, so it is within the critical region. That means we should reject the null hypothesis, or H0. So we can say as 15 is in the critical region at 10% significance. And then we should add a little bit of context to show that we're understanding, or I should say, because the question is in context, because they've said explain what Sam should conclude, we should give some context in our answer. And we should say something like, there's evidence that the wind directions are not equally likely. So there is evidence that wind directions are not equally likely in Hern, or not all equally likely. Okay, and that was question 3 for a total of 8 marks. Question 4 says a large number of runners take part in a running time trial. A random sample of these runners are selected and the times in minutes are summarized in the following statistics. We have the sum of the variables equals 800, so the sum of the times. The sum of the squares equals 81,760, and we have n equal to 40. So this sample has a sample size of 40. Part A says calculate for this sample the value of the mean and the standard deviation. Okay, so mean, hopefully you're familiar with how to calculate the mean. It's the sum of all the variables divided by how many variables or how many samples there are. So, the mean of this is going to be 1800 divided by 40, which if we put into a calculator, we get 45. Okay, so that's the mean. Part 2, for the standard deviation, there are 2 ways or 2 formulas we typically have to find the standard deviation, and these are in your formula booklet. So we can say the standard deviation squared is the sum of the difference of squares, in other words, x take x bar all squared divided by n, or we can use standard deviation squared equals the sum of the squares divided by n take x bar squared, or the mean squared. So I'm hoping you're familiar with these and all of the reasoning behind them. This second one is derived from the first one, and I would suggest using the second one here because we have the sum of the squares already. We just calculated the mean. That's going to make calculating this standard deviation pretty straightforward. So we can say the standard deviation squared is the sum of the squares, 81,760 divided by 40, take 45 squared. And then it's just, straightforward calculation. And I get 19, and then we need to take the square root of that to get the standard deviation. So 4.35 and so on. 4.358898. And let's round that off to 3 significant figures, so 4.36. Part B says, historically, the mean time for runners on this time trial has been 44 minutes. Lara is watching the time trial and believes that the mean time of runners in this time trial is greater than the mean time of runners in previous time trials. The times of runners on this time trial are modeled by a normal distribution with standard deviation of 4 minutes. Test at the 5% level of significance whether or not this sample provides evidence to support Lucy's belief. You should state your hypothesis and show you're working clearly. Okay, for part B, What will be our hypothesis? Well, the null hypothesis, or H0, is always things are the same. In other words, we assume that the mean will stay at 44 minutes. So mu equals 44. And then our alternate hypothesis is the thing that we're trying to test for. In this case, Lara is trying to see if the mean time is greater than 44. So that's our alternate hypothesis. The mean is greater than 44. And we have an alpha, or, level of significance of 5%. So alpha is 0.05. Okay, keep in mind, this was a sample. So the mean we got here was a sample mean. And the mean we're talking about here is the population mean. In other words, the mean of all of the runners, not just 40, but all of the runners taking part in the running time trial. So that's what we're testing. So to do this, we talk about the standard error of the mean. This is like the standard deviation of all of the sample means. So let's say we took another 50 samples of 40 from this population. They would each have their own sample mean, and the standard error of the mean is the distribution of those sample means. To calculate the standard error of the mean, which we write as SE x bar, we take the standard deviation, which they've given us, and divide by the sample size, the square root of the sample size, in this case 40. There are some really good videos on YouTube as to why we do this, so I won't explain it here. Let's just write that a bit neater. That's standard deviation divided by the square root of 40. Okay, and so the standard deviation they've given us is 4, the square root of 40. That's our sample size, and that's what we need to calculate. So here we have 4 divided by the square root of 40, 0.6324, which I'll round off to 0.632. That should be enough. Okay, so think of that as your standard deviation of the sample means. In other words, we're doing normal distribution of the sample means, not the sample itself. Then we need a critical value. Critical value for 0.05%. So you can look that up in the table, or you can calculate it using your calculator. So you can use inverse norm, 0.05 gives you 1.6449. It's the same value you get from your table as well. The only reason it's negative there again is because I'm using 0.05 instead of 0.95. Just ignore the negative, it's fine. So the critical value is 1.6449. Okay, so we need to find whether our test is within that critical region. So we want to find a z-score for our test statistic. Our value is the mean that we got from our sample, 45. Take the population mean, 44, divided by the standard error of the mean, 0.632. Then calculate this and see if it's within the critical region. So 45 take 44 divided by 0.632. And I get 1.58, just less than the critical value. So let's say this is 1.58. It's not in the critical region. It's less than the critical region. So there is insufficient evidence to support Lara's belief. That's what you need to finish up with here. So not within the critical region, so there is insufficient evidence to support Lara's belief. Or in other words, the alternate hypothesis that the population mean is greater than 44. Okay, that was part B. Part C says Fun and Fitness Running Club entered its 5 fastest runners and 5 beginners to take part in the time trial. The fastest 20% of the runners in the time trial are invited to compete in a race the following week. Part 1 says explain with specific reference to the parameter P why the distribution B10.2 might not be reasonable to model the number of these Fun and Fitness Running Club members who are invited to compete in the race. Okay, so you need to know what this notation is referring to. Okay, let's go down the page a bit. So for part C, part 1, B10.2 refers to a binomial distribution with a sample size of 10 and a probability of success of each person in the sample of 20%. So if we think about this, the context of this question, we have the 5 fastest runners from the club and 5 beginners. Will each person have the same chance of success of being invited to compete in a race? Probably not. Probably the 5 fastest runners will have a higher chance of success than the beginners. So that's why this binomial distribution with the same probability of success for each runner is not appropriate. So I'll try to write some of that down here. So I've said in a binomial distribution with p equal to 0.2 is assumed that each person has a 20% chance of success, but in this race, the fastest runners will have a higher chance of success than the beginners, so the model is not appropriate. Okay, part 2 says suggest how to improve the model for the number of these fun and fitness running club members invited to compete in the race. So for this, well, think about how you might model the 5 fastest runners and the 5 beginners. You'd probably want 2 separate distributions. You'd want a chance of success for the fastest runners and a chance of success for the 5 beginners and group those together. So I would say use 2 separate models here. So use 2 independent binomial distributions with n equals 5 for each, but different values of p to represent the fact that the fastest runners will have higher chance than the beginners. Okay, that was question 4 for a total of 11 marks. Question 5, this is the last question of the statistics section. It says the 2 events A and B are mutually exclusive, given that P of B equals P, and that does not equal 0, and P of A equals 4 times PB. Draw a Venn diagram to illustrate this information and find the possible values of PB. Okay, so you need to know what mutually exclusive means, and if you know what that means, then this question is pretty straightforward. Mutually exclusive is these 2 events cannot happen at the same time. There's no intersection. It's like, it's raining or it's not raining. The sun is up or it's nighttime type of thing. You cannot have any crossover. Well, maybe that last one was a bad example because you could say the sunset is technically nighttime and daytime. I don't know. Anyways, raining, not raining. 2 events that cannot happen at the same time, they're mutually exclusive. So if P of A and P of B are mutually exclusive, the Venn diagram will be 2 separate circles. There'll be no intersection. And P of A is 4 times PB. So if we called this circle B, then A would be 4 times that. So let's just draw a bigger circle to indicate that. And this was, the probability of B happening was P, and this is going to be 4P. Now, to finish this Venn diagram off, you could draw a rectangle around it, but I don't think you need to do that. You just needed to mainly show the circles, and this was A, and that was part A. So for part B, it says find the possible values of PB. Well, what are the possible values of P? Remember, the maximum value of the probabilities is 1, so we would have that P plus 4P is less than or equal to 1. It could not be more than 1. So then we can add 4P and P. That would be 5P less than 1, less than or equal to 1. So P is less than or equal to 1/5. And P was the probability of B. So, P of B is less than or equal to 1/5. So that's the possible values of PB. Part 2 says 2 events C and D are such that the probability of C given D equals 4 multiplied by the probability of C, where P of C does not equal 0. Explain whether or not events C and D could be independent events. So part 2, part A. Independent events means that one does not affect the other. So the probability of D, or the event D, does not affect the probability of event C happening. If you know what this notation means, this statement should say to you these are not independent events, because this is the probability of C given that D happened. And if this is not equal to the probability of C, or PC, that means D affected the probability of C. So this statement by itself says that these are not independent events. So we can say that as P of C given D does not equal the probability of C, then they are not independent events. Part B says, given also that the probability of C intersect D equals a third of the probability of C, and P of C complement intersect D complement equals 3/8, find PC showing you're working clearly. I guess this question is really all about knowing your set notation, so knowing what these expressions mean, what these equations mean. So I'll go on to the next page for this one. Let's firstly look at this equation. P complement C intersect D complement. So for part B, let's write that down. What does this mean? Well, this means it's not in C and it's not in D. In other words, if we draw a Venn diagram of this situation, and we'll have the two events C and D, and they'll have some intersection in here, which is a third of the probability of C. C complement intersect D complement is everything outside of the two events. In other words, it's not in C and it's not in D, so it's the rest of the probabilities, and they've told us that's 3/8, so that would go in here. Okay, what else? Well, this information is still part of this question, so we still have that the probability of C given D equals 4 times PC, and now we're also told that the probability of C intersect D equals a third PC. If you know the formula for conditional probability, then you know that that is part of it. So the probability of C given D, there's a formula for this, is the probability of C intersect D over the probability of D. This actually allows you to solve for the probability of D, because we can plug in a third PC into here. We also know that the probability of C given D is 4 times PC, so plugging these into this equation, we get 4 multiplied by the probability of C equal to a third times the probability of C over PD. This equation allows you to solve for PD because the PC's will cancel. Probability of C will cancel. Okay, so rearranging this, multiplied by PD and then divide by PC, divide by 4. We're going to have a third divided by 4. That's going to be 1/12. So the probability of D turns out to be 1/12. So that's going to go in here. Now all we need to work out is the probability of C. Well, these need to add up to 1. So we could say 3/8 plus a 12th. 3/8 plus a 12th plus PC should equal 1. Our common factor here is 24. So multiply this by 2, multiply this by 3. This would be 9 on 24 plus 2 on 24 plus PC equals 1. So 11 on 24 plus PC equals 1. Hopefully you can see there it's going to be 13. So the probability of C equals 13. That is one way to tackle that question. There are different methods to solve that, but I think the main point is you needed to use this equation here, this one for conditional probability, and you also needed to know what this notation meant. As long as you knew those two things, I think you'd be fine with that question. Okay, so that's the statistics section. Let's move on to mechanics. Question 1 of the mechanics section says, at time t seconds where t is greater than or equal to 0, particle P is modeled as having velocity v meters per second, where v equals 6t squared, take 24ti, plus 12t squared, take 5tj, and having acceleration a meters per second squared. Part A says find a in terms of I, j, and t. So acceleration is the change in velocity with respect to time. In other words, we need to differentiate this vector or equation for v to find the acceleration. So let's write down v first. This is 6t squared, take 24t, I, plus 12t squared, take 5t, j. So now we want to differentiate, and you can use the power rule on each term. So the exponent is multiplied by the coefficient. That gives you the new coefficient. And if it's just 24t, the derivative will be 24. So then we have 2 times 12, 24, 24t take 5, cannot write today, 5j. Okay, so that's acceleration in meters per second squared. Part B says when t equals 0, p is at the origin O at time t seconds. P has position vector r meters relative to O. Find r in terms of I, j, and t. Acceleration is differentiation. Position is integration of the velocity. So now we want to integrate v with respect to t. Here again we can use the power rule for integration. So add 1 to each exponent, then divide. So 2 plus 1 is 3. 6 divided by 3 is 2. 2t cubed. Then 1 plus 1 is 2. 24 divided by 2 is 12. T squared. Then we have 12 divided by 3. That's 4t cubed. And 5 on 2t squared. J. Okay, so that's position. That's part B. Part C says at the instant when A equals lambda j, where lambda is a constant, P is at the point A, find the position vector of A relative to O. Okay, what is this piece of information telling you? Well, that means that the I vector is equal to 0 because we only have something j. We don't have any I vector in that expression. So if we look at the equation for acceleration, this part is equal to 0. That's going to allow us to solve for t, the time. 12t take 24 equals 0. Then we can see that t must equal 2. Then we can plug that in here and find r. So r is going to equal 2 multiplied by 2 cubed. Take 12 multiplied by 2 squared. I plus 4 multiplied by 2 cubed. Take 5 on 2 multiplied by 2 squared. J. So I've taken that time, plugged it in for t in this equation here. So then this is 8 times 2 is 16. Take 12 times 4, that's 48. I plus 4 times 8 is 32. 5 on 2 multiplied by 4, that's 5 multiplied by 2, that's 10. J. 16 take 48 is negative 32. I. Then 32 take 10, that's 22j. So now we have our position vector, we have our answer for part C, and we're done with question 1 for a total of 8 marks. Question 2 says a beam AB has weight 30 newtons and length 4 meters. The beam is freely hinged at the end A to a vertical wall. The beam is held in equilibrium at an angle of 45 degrees to the wall by a rope. One end of the rope is attached to the point C on the beam where AC equals 3 meters. The other end of the rope is attached to a point D on the wall where D is vertically above A. The rope is perpendicular to the beam as shown in the figure. The rope and the beam lie in a vertical plane that is perpendicular to the wall. The beam is modelled as a uniform rod and the rope as a light inextensible string. Using the model, find the tension in the rope. Okay, so all of this information essentially summarizes this figure. We have the beam AB. It's held by this rope DC, which is 90 degrees to the beam. The angle between the beam and the wall is 45 degrees. The beam is 4 meters long. Also, they tell us it has a weight 30 newtons. And as it's a uniform rod, that weight will be acting at the center of the rod, straight down. Okay, so that's a force of 30 newtons. And we're looking for the tension in the rope. Okay, to do this, the idea is to find the moments about A, because there will be forces acting on this beam from the wall at A. However, if we take the moments around A, we don't have to consider them. That's the idea of moments, right? If you have forces acting on that beam at the point that you're taking moments about, they're not going to have any effect. We're thinking about, how this beam rotates around that point. The forces at A we don't need to consider. We only need to consider the tension and the perpendicular component of the weight. And this angle is going to be the same as this angle because these lines are parallel, these are perpendicular, so this will be 45. this component of the weight will be 30 multiplied by the cosine of 45. And then we need to consider the distance from A. So the tension is 3 meters from A. They tell us that in the question. So we're going to have that the moments about A are that 3 multiplied by the tension force is equal to half of 4 meters. This was in the center, so half of 4 is 2. So we're going to have 2 multiplied by 30 cosine 45. They are equal because the rod is in equilibrium, so these two forces must be the same. This allows us to solve for T. So we can say that T will equal 2 multiplied by 30 cosine 45. Cosine 45 is root 2 on 2. Let's make a note of that. Cosine of 45 equals root 2 on 2. You can also use 1 on root 2. They're the same thing. So over here we're going to have 60 multiplied by root 2 divided by 2. But if I'm dividing by 3 as well, this is going to be divided by 6. So the tension force then is 10 root 2 newtons. Okay, so that was part A. Part B says find the magnitude of the resultant force acting on the beam at A. For the resultant force, you want to consider the net force acting in the vertical direction and the net force acting in the horizontal direction. And that gives you your resultant force. If you add those two vectors together essentially. Okay, so how can we find the net vertical force and the net horizontal force? Well, we can resolve vertically. So let's consider all of the vertical forces acting on this beam. Well, really we only have the tension force, the vertical component of the tension force, and the weight. They're the only forces acting on this beam. So then we can say the vertical component of the forces acting at A, let's call that Y, will equal the tension force pulling up. I'm going to take up as positive. And by the way, this angle in here will be 45 because these are parallel. This is perpendicular. So this is going to be T cosine 45 as this vector is adjacent to the angle. So it's going to be the vertical component of tension pulling up, T cosine 45, take the weight pulling down, so 30. That will be the vertical component at A. Then let's resolve horizontally, and we'll take going right as positive. Let's call this X. The only force acting in the horizontal direction is going to be the horizontal component of tension. The weight is just straight down, so we won't have a horizontal component of weight. So this is going to be T sine of 45 because it's opposite that angle. And also it's pulling towards the wall, so I'm going to say this is a negative value because I'm saying going to the right is positive. So this will be negative T sine 45 for the horizontal component of this resultant force. So now let's get some values for these. Let's calculate Y. T is 10 root 2. Cosine 45 is root 2 on 2. And then we need to subtract 30. So this would be 10 times 2 on 2. In other words, this whole thing will evaluate to 10. Subtract 30, that will give me a value of negative 20. X, this is negative 10 root 2 multiplied by root 2 on 2. So this is 10 multiplied by 2 divided by 2. In other words, just itself. Or you could think of that as 2 divided by 2 is just 1. So we get negative 10 there. Okay, so now we have that actually we could redraw these vectors. You don't have to do this, but we have a resultant force or the vertical net force at A pulling down because I get a negative here, and the horizontal force pulling this way. So our resultant force will be in this direction. And to find the magnitude, well, we use Pythagoras. This is a right angle triangle. So the magnitude of the resultant force will be the square root of these squared. So 20 squared plus 10 squared. That is the square root of 500, which we could write as 10 root 5 newtons. Okay, so there you go. That was part B. That's how you find the magnitude of the resultant force when you're talking about hinged beams and things like that. Part C says, if the rope was not modeled as being light, state how this would affect the tension along the rope, explaining your answer. So if you assume the rope has weight, that means that the top of the rope is going to be holding more weight than the bottom of the rope. So there'll be, like if we take the point here, for example, there'll be more weight pulling down than at the bottom of the rope. That means the tension in the rope will not be constant. As you go further up the rope, the tension will increase. I'll just try to summarize that. So the tension force would increase as you go up the rope, and the tension force in the rope will not be constant. That was question 2 for a total of 11 marks. Question 3 says a train X runs on a straight horizontal track that connects station A and C. Station B lies between A and C. The figure shows the graph of the speed v meters per second of train X against the time t minutes after noon. Train X leaves A at noon and accelerates uniformly from rest until t equals 2, when it is moving with speed 18 meters per second. Train X then continues to move along the track at a constant speed for 12 minutes before decelerating uniformly and coming to rest at B at time t equals 16. Train X leaves B at time t equals 19 and accelerates uniformly for 2 minutes, reaching a speed of 18 meters per second. Train X then moves along the track at a constant speed of 18 meters per second for 13 minutes before decelerating uniformly and coming to rest at C at time t equals 36. So you can see in the graph, this is where the train's accelerating. This is where it's traveling at 18 meters per second. Then it decelerates. That would be station B. Then it leaves and travels to station C. Part A says, find the distance of C from A, stating the units of your answer. When you're given a speed time graph or a velocity time graph, the distance is the area under the graph, because distance is speed multiplied by time. So we want to find the area under this graph, but we need to be careful with our units because the speed is in meters per second and time is in minutes. So we want to convert the time to seconds first. In other words, we multiply all of the times by 60 and then we can get our area. So the total area is going to be the area of these trapezia or trapeziums. And you know how to find the area of a trapezium. It's the top length. Here the top length is 12, the bottom is 16, the height is 18, and for this one the top length is 13, the bottom is 17, and the height again is 18. So we also want to multiply all of these by 60. So for the first trapezium, we're going to have 12 multiplied by 60 plus 16 multiplied by 60 multiplied by the height, which is 18, and then divided by 2, plus 13 multiplied by 60 plus 17 multiplied by 60 multiplied by 18, and that is divided by 2. And that should give us the total distance between A and C. So let's plug that into a calculator. So 12 multiplied by 60 plus 16 multiplied by 60. I'll just go ahead and plug all of this in. And you should get an answer there of 31,320 meters. Okay, so that was part A, just finding the area. Part B says a second train Y leaves A at t minutes after noon and moves in the same direction as train X on a parallel straight horizontal track. Train Y accelerates uniformly from rest for 1.5 minutes, reaching a speed of 25 meters per second. Train Y then moves along the track at a constant speed of 25 meters per second and passes C at this speed. Train Y passes C at the instant train X stops at C. Find the value of t. So t is the time that train Y leaves station A. So that's going to be somewhere here on our graph. Then it accelerates up to 25 meters per second, and then it zooms past station C just when train X is getting there. So in other words, 36 minutes after noon, it will go past station C. Okay, so how can we find this time here? I'll just erase that 16. How can we find t? Well, we know that train Y has traveled the same distance as train X because it's left from the same station and arrives just when train X is pulling into station C. So they've both traveled the same distance. we can use this value we've calculated then to find when it left the station. To do that, we're going to find the area or an expression for the area under this graph we've just drawn. So we know that it accelerated for 1.5 minutes. So we know this length here, or the base of this triangle, will be 1.5. And we don't know the length of this rectangle. So let's just give that a variable, or sorry, let's give that a letter. Let's just say that's m. And so let's write an expression for this area for the distance that train y has traveled. So for b, well, first we have the area of this triangle. So that would be 1.5 multiplied by 60 multiplied by the height, which is 25, because it was traveling 25 meters per second. That's divided by 2. Then we have the area of this rectangle. So that's going to be m multiplied by 25. In other words, 25m. And this needs to equal the same distance, so 31,320. Then we can solve this for m. And we can find the time that it left the station by subtracting them from 36. So, well, let's evaluate this and then subtract it from 31,320. So 1.5 multiplied by 60 multiplied by 25 divided by 2 gives us 1,125. So let's subtract that answer, and I get 30,195. So then we have 25m equal to 30,195, and so m is equal to that divided by 25. Oops. So you should get 1,207.8 here. And remember, that's in seconds. So because we're looking for t in minutes, let's convert this to minutes. Divide by 60. That's 20.13 minutes. So t is going to be 36. Subtract 1.5, subtract 20.13. So 36 take 1.5, take 20.13, and I get 14.37. So t is equal to 14.37. So that was part B. Part C says state one assumption you made in your working that could affect the accuracy of your answer to part B. This is a tricky question, but the assumption you're making here is that the trains are essentially particles, right? Because you're assuming there's, the entire train arrives at the same time, and also you're modeling the stops, the stations, as points. So the entire train leaves the station in one moment, and it arrives the whole train arrives at the exact same moment. And also at the end, when train Y is passing train X, we're assuming the whole train passes train X all at the same time, which is not realistic. So that might affect the accuracy. So for part C, we can say we're modeling the stops as points and we're modeling the trains as particles. That was part C for 1 mark, and that was question 3 for a total of 9 marks. Question 4 says a package P of weight 10 newtons is moving up an inclined plane under the action of a horizontal force of magnitude 20 newtons as shown in the figure. The force is acting on a vertical plane through a line of greatest slope of the plane. The coefficient of friction between P and the plane is mu. The plane is inclined at an angle of alpha to the horizontal, where tan of alpha equals 3/4. Package P is modeled as a particle, and part A says find the magnitude of the normal reaction force of the plane on P. So let's draw some forces in on this diagram. Firstly, we have the weight pulling straight down. Then we have some net force pushing the particle up the plane. We'll have friction, which is always in the opposite direction of movement. If I can draw. Okay, so this is 10 newtons. We don't know the net force yet. We don't know friction, and we are looking for the normal force, which pushes up from the plane, and we label this R. To find the normal force, we want to find all of the forces acting perpendicular to the plane. So this is going to be the perpendicular component of weight. This angle in here is alpha because this line is perpendicular to the plane and this line is perpendicular to the ground. So we have a similar triangle. So this angle is alpha. That means this component will be 10 cosine alpha because it's adjacent to the angle. Then we'll also have some component of the thrust force pushing down as well because it's pushing into the plane. So we're going to have a parallel component of that force and a perpendicular component. And this angle in here is also alpha. Again, this is a similar triangle. This component in here is going to be 20 sine alpha because it's opposite to the angle. And they are the only two forces acting perpendicular to this plane. So the normal force will be in reaction to those two forces. So for part A, we can say that R is equal to 20 sine alpha plus 10 cosine alpha. And they tell us tan of alpha is 3 on 4. So we can find sine alpha and cosine alpha by drawing a little right triangle. So the tangent ratio is opposite over adjacent. So let's draw a little right triangle with alpha. Opposite side is 3. The adjacent side is 4. Hopefully you know or recognize this right triangle. 3, 4. What's the hypotenuse? That'll be 5. So sine of alpha is opposite over hypotenuse. That's 3 on 5. So this will be 20 multiplied by 3 on 5 plus 10 multiplied by 4 on 5. Cosine alpha is adjacent over hypotenuse. 20 on 5 is 4. 4 times 3 is 12 plus 2 times 4 is 8. So for the normal force, we're going to get 20 newtons pushing up from the plane. Part B says find the range of possible values of mu, the coefficient of friction. Okay, so for part B, we want to consider all of the forces acting parallel to the plane. So this is going to be the parallel component of the thrust. So this one here is going to be 20 cosine alpha. And also we have a parallel component of weight pulling down. So that is going to be 10 sine alpha. So that's, hopefully you can see that, that's the parallel component of the weight force. Okay, so they're the only forces acting in the direction of motion, if you like, along the plane. So we can use those to find the net force pushing the particle up the plane. So we'll call that F or F net. Okay, so F net is going to be 20 cosine alpha, the thrust pushing the particle, subtract the weight force pulling down, so 10 sine alpha. So cosine alpha we said was 4 on 5. Sine alpha was 3 on 5. So what do we get here? We get 16 subtract 6, so that's 10. So we have a net force of 10 newtons parallel to the plane, up the plane. Now friction is going to be opposing that, and because this force is pushing the particle up the plane, we can either have a positive acceleration or just zero acceleration. So it's just moving up the plane, it's not accelerating at all, or it could be accelerating. In that case, friction is either going to be equal to the net force, in other words, the particle is just moving up the plane, it's not accelerating, or it's going to be less than the net force. So we say, well, friction is mu multiplied by the normal force, R. So we say this is less than or equal to the net force up the plane, so 10. R we calculated in part A, so this is going to be mu times 20 is less than or equal to 10. So then mu is less than or equal to a half. So that's part B. Part C says the horizontal force is now removed and P continues to slide up the plane until P comes to an instantaneous rest. Package P then slides back down the plane. Given that mu equals a third, find the acceleration of P as it slides down the plane. Okay, so for part C, we now have that mu equals a third. And to find acceleration, we're going to be using this equation, F equals ma, and rearrange it to find a. So a is going to be F on m. We know the mass because we know the weight, which is 10 newtons. We can divide that by 9.8 to get the mass, but we don't know the net force at the moment. We knew the net force for part B when we had the thrust pushing the particle, but now that thrust is no longer there. Oops, I don't know what happened there. Now that thrust is no longer there, the normal force is going to change and the net force is going to change. So we could essentially erase all of this. We no longer have this guy. That's no longer there. So really the only force acting on the particle is weight. So that means the normal force is going to change. So let's firstly recalculate the normal force. So R is now only equal to this perpendicular component of weight, so 10 cosine alpha. Okay, 10 cosine alpha. And that was, forgotten what cosine alpha was. Cosine alpha was 4 on 5. So 10 multiplied by 4 on 5, which was 8 newtons. So the normal force is 8 newtons. Also, the only force pulling the particle down is the parallel component of the weight force, so 10 sine alpha. And now friction is no longer pointing this way, it's in the opposite direction of motion. So friction is now pushing or dragging the particle, or how do you say this? Not pushing the particle up the plane, but it's acting up the plane. So friction is now acting up the plane in opposition to the weight. So we can find the new net force, so F net for part C will be what will it be? It will be 10 sine alpha, that's the weight pulling down, subtract friction, which is mu, multiplied by the normal force, so a third multiplied by 8. Okay, that will give us F net pulling down the plane. Got a bit confused there, hopefully you followed that. Okay, so 10 sine alpha, we have sine alpha, that was 3 on 5. So actually I don't know my calculator just yet. 10 multiplied by 3 on 5, take 8 on 3. This is going to be 6, take 8 on 3. Okay, now let's get a decimal for that. 6 take 8 on 3. Actually, maybe a fraction will be more useful. So this will be 18 take 8 on 3, which is 10 on 3. Okay, so we have F net acting down the plane, and that's actually all we needed to find acceleration, right? So acceleration is now 10 on 3, the net force divided by the mass. So as I was saying, to get the mass, we want to divide the weight force, 10 newtons, by g. Okay, so A is 10 on 3 divided by 10 on g. To divide fractions, we flip and multiply. So this is going to be 10 on 3 multiplied by g on 10. In other words, g on 3. And you could leave your answer as this if you like, or you could get a decimal answer. I think this will be fine. So final answer for part C is g on 3 meters per second squared. And that was question 4 for a total of 11 marks. Question 5 says a small ball is projected with speed u from a point O on horizontal ground. When the ball has moved horizontal distance x, its height above the ground is y. The angle of projection is theta to the horizontal, where theta is between 0 and 90 degrees. The ball is modeled as a particle moving freely under gravity. Part A says show that according to the model, y equals x tan theta take g x squared over 2u squared cosine squared theta. Okay, firstly I want to draw a diagram. So we're projecting a ball at some speed u, and it travels through the air, and when it gets to any point in that path, we have a horizontal distance x and a vertical distance of y. Okay, and we want to find some expression for y. Okay, these projection type questions, usually involve breaking the speed of the projection into its vertical component and its horizontal component. And by the way, this angle was theta. So the vertical component is u sine theta, and the horizontal component is u cosine theta. So how can we get this expression, x tan theta take g x squared over 2u squared cosine squared? I'm hoping you're thinking of your Suvat equations. So you're thinking s equals ut plus half at squared, and hopefully you see a connection between this and that formula. It looks similar. We have obviously different, terms in here, but it looks like we might get this if we use s equals ut plus a half at squared. But there's something we're missing here. We don't have time. We don't have an expression for time. So what could time be here? Well, if we have the speed in the horizontal direction and we're representing the horizontal distance as x, and we know that time equals distance divided by speed, then we could represent that time with respect to x. So we can say t equals the horizontal distance, x, divided by the horizontal speed, u cosine theta. Okay, so we have an expression for t. And if you're wondering, how would you even think about getting started here? I would start by looking at the Suvat equations. So try to make a connection between this expression and one of those. All of them are in your formula booklet, so you can look at them and see, which one have they likely used? Then I would think about, okay, what do I want time in terms of? In here we have y in terms of x, so we likely want to have time in terms of x. So that's how my thought process would get me started here. If you're wondering, like if you get a question like this, where to start. So anyways, we have t equals x over u cosine theta. And as we're representing the vertical distance, this s is going to be y and u is going to be the vertical speed. So we're going to have u sine theta for the vertical speed, the starting speed, that's what u stands for, multiplied by t, which is x over u cosine theta, plus 1/2. A is g, and t squared will be this squared. So x on u cosine theta all squared. And now we see, well, this is probably going to simplify to this already. So the u's cancel in this first term. Sine theta over cosine theta is tan theta, so we get x tan theta plus gx squared. And actually, it's going to be subtract because acceleration acts in the opposite direction to the vertical speed. So that's where that negative is coming from. I actually made an error there. So that's a negative gx squared over 2u squared cosine squared. Okay, and we're there already. Part B says a golfer hits a golf ball from a point X on horizontal ground. The golf ball just passes over the top of a 10-meter tall tree, which is 45 meters from X. The golf ball is modeled as a particle moving freely under gravity. Given that the angle of projection is 30 degrees to the horizontal, find the speed of the ball as it passes over the tree. Okay, for part B, we're given the horizontal distance, we're given the vertical distance, we're given the angle of projection. What are we missing? We're missing the original speed of projection. So if we draw a little diagram, we have the ball is projected at 30 degrees. It travels through the air, just passes over a tree, 10 meters tall, and it's gone 45 meters in the horizontal distance, but we don't have u. So hopefully you see how we're going to find u. We're going to use the equation we found in part A. Plug all of these values in and then solve for u. So y is 10, x is 45, theta is 30, g I'm just going to write as g, but we know g is 9.8. It's multiplied by 45 squared over 2u squared cosine squared of 30. Okay, now we need to rearrange this in terms of u. This is going to be a bit messy algebraically. So the first thing I would do is subtract this term. So we've got negative g 45 squared over 2u squared cosine squared of 30 is equal to 10 take 45 tan of 30. Then I'd multiply by this denominator, divide by this term here. So we will have 2u squared cosine squared of 30 equal to negative g 45 squared over 10 take 45 tan of 30. So I'm going to evaluate that first. So this is negative 9.8 multiplied by 45 squared divided by 10 subtract 45 multiplied by the tangent of 30. Okay, so that's that answer. Then I need to divide that by 2 cosine squared 30. So 2 times the cosine of 30 squared. And that's u squared. So u squared is 827.87. Then to get u, we need to take the square root of that answer. So that's 28.7727. Okay, so that's the original speed. We haven't answered the question yet because we want the speed as the ball passes over the tree, but we needed this original speed to work that out. Now to find the speed of the ball as it passes over the tree, we only need to find the change in the vertical component of the speed because there's nothing affecting the horizontal component. So firstly, we want to break this original speed up into its horizontal and vertical components. So uy is equal to u sine 30. So let's calculate that first. So let's take that answer, multiply it by sine of 30. That's 14.38 and so on. Actually, I might need to write down a few more decimal places just in case. Okay, then ux is u cosine 30. So I get 24.9179 for the horizontal component of the speed. Now we just need to calculate how gravity affects the vertical component after it's traveled 10 meters. To do that, we can use this equation, v squared equals u squared plus 2as. Because we have the original speed, we have acceleration, we have displacement. That will give us the new speed after it's gone 10 meters in the air. So plug in these values. V squared is going to be 14.38636 squared. Subtract this part because the acceleration is, or the gravity is pulling the ball down. So subtract 2 times 9.8 multiplied by 10. Let's plug that in. That gives me 10.96, but I need the square root of that to get V. So the new vertical speed is 3.3116 and so on. Okay, now that I have that new vertical speed after it's gone 10 meters in the air, I can calculate the speed of the ball as it's traveling over the tree. So to do that, we find the resultant. In other words, what are we calling this? V is equal to the square root, and I should have called this Vy, by the way. So the new speed is this answer, 3.3116 squared, plus our horizontal component of the speed, 24.9179 squared, and that will give us our answer. So our last answer squared plus 24.9179 squared, and I get 25.137. 25.137. Rounding that off to 3 significant figures, that would be 25.1 meters per second for the speed of the ball as it passes over the tree. Okay, that's the last question of this paper. I hope you found that video useful. Please leave a like if you did, and I'll see you in the next one. Bye for now.